Okay, so welcome back. So things have been going pretty slowly so far, but I think this is going to be the start of where things start picking up just a little bit. The most important thing, and I cannot stress this enough, is that you have to understand the content of each one of these videos before you move on to the next. All right. If you have to watch a video more than once, that's fine. Do it. If you have to go back and rewatch some videos because you're lost, do it. But do not assume that things are going to get easier as we go along. Okay, this is the start point where we're going to start actually learning real things and how to do real commands in a program, and it's not going to get easier. I'm going to talk about variables in this video. And once this video is over, I'm going to assume that you know what variables are and you know how to use them, and I'm going to assume that I don't have to say another word describing them as I use them all over the place. Okay, so just take your time, become comfortable with the material we're doing, and then move on. All right, so let's go ahead and get started. So let's talk about variables. All right, so the thing about variables, every program has a region, something called memory. And memory is where the program stores information that it is working with. Okay, if it's doing a calculation, it's going to keep all of the numbers inside memory. If you're reading a file, it's going to load the file into memory. Everything that a program does deals directly with memory. All right, and the most basic way of storing information inside memory is through what is called a variable. All right, we're going to cover how to create a variable in just a minute. But the important thing that you need to realize is when you create a variable, the program, C++, will go into memory for you, and it will create a little box. And inside, or in that box is going to be a small little region of memory that is given to you to store information. All right. And when you create this variable, every variable has three things. First, it has a name. And this name is important because this is how you're going to access this region of memory. This is how you're going to differentiate this region of memory from other regions of memory. It's going to give you access to memory. All right. The second thing that every variable has is it has a data type. And a data type says what kind of data is being stored in memory. All right, so for example, this could be a number, it could be a character. There are a bunch of different types that we're going to go over, but every location in memory, you have to tell C++ what kind of data you want stored there. And the third thing that every variable has is it has a value. All right. And this value is the actual information we want. This is the actual value, this is the actual data that we are storing in memory. All right, so every time you create a variable, it's going to have all three of these things. We're going to give it a name so we can access it later. We're going to tell C++ what type of data we want to store, and then we're going to give it a value. The most important thing about this value is that the values in variables can change. This is important, particularly when you're coming from a math background. So when you're in math, if you have an equation and you're solving for x, x has one value. All right. In computer science, when you have a variable, it can have any value you want to give it, and you can change it at any time. That's why it's called a variable. It's allowed to vary. This is just something that for some reason people can sometimes have a difficult time getting this. They can have a difficult time understanding. They think that if they create a variable, it has a value and that's it. No, we can and will change variables all the time. in order to make our programs do what we want them to do. All right, just think of it as the variable is the box inside memory where we store a value, and we can change it at any time, we can read it at any time, but that all the variable is it's the container where we store a very small piece of information. And what we're going to do is we're going to create variables all over the place in our program, and we're going to decide what our program should do based on the information that's in those variables. All right, so let's talk about data types. So when I was up here, I said the second thing that everything has is a data type. Let's talk about just a few types of data. We're going to cover all of them before the end of this video, but I just want to give you a taste of what three of them are. Okay, so the first one that is very common is called an int. An int stands for an integer. And an integer just means any, well, almost any number that does not have a decimal point. All right, so this can be 0, it can be 10, it can be 123, it can be -5. It can be almost any number as long as that is a whole number and doesn't have a decimal point. The next type, I will say, is a char. Okay. And char stands for character. And a character is any single letter or symbol. And this is basically, if you look down at your keyboard, anything that's on your keyboard is a character. You know, all the numbers that are on there can be characters, all the letters, capital, lowercase, all the fancy symbols. That's just what a character is. It stores a single one of those. All right. And then the last type that we will cover to start off with is a float. And a float is short for floating point number. And this is for storing any, and again I'll say almost any, number that does have a decimal point. Okay, so this can be 3.4, it can be 1.4 times 10 to the 14th. You know, it can even be 3.0. It doesn't have to. You can store integers inside floats, but floats have the ability to store fractions of a number. All right, and the floating point refers to the way that when you write numbers in scientific notation, that decimal point floats across the number. And so, like when I said 1.4 times 10 to the 14th, you know, that decimal point floats up to 14 places to the left of where it would normally be. That's where the name comes from. It doesn't really matter, but that just kind of helps you understand why we use such a strange name for a number that has a decimal point in it. All right, so these are three of them. We'll cover a few more later, but I just want to give you a taste of what kind of data types there are. Whenever I create a variable with one of these data types, C++ is going to make a special box that is meant to hold that kind of data. And if we try to store something else in it, it is going to either, if it can, it will force it to be the right type, or it will throw an error. Okay, we have to say what kind of data we actually want to go in the box that we create. So let's talk about, when we're dealing with variables, there are three things that we can do. And we're going to call them variable declaration, assignment, and initialization. Those are really long words, for some really simple concepts. Okay? All this means, declaration is the act of creating a variable. Okay. As we use variables, the important thing to realize is that this process right here of creating a box in memory and giving it a type and giving it a name and giving a value, this process does not happen automatically. We have to ask the program to do it. And when we ask, it is at the moment we ask that we actually have this box and are allowed to use it. So before we can do anything with variables, we have to create the variable. And declaration is about creating the variable. All right, the second one is assignment. And this is where we assign a value. If I can write. All right. Assignment, when we create a variable, we don't necessarily give it a value. All you're going to have is an empty box without a value in it. Assignment is the act of giving a new value to a variable in memory. Whenever we do an assignment, whatever value was there before is going to be erased, and we're going to get a new value inside that variable. This is it's not too hard of a thing, but just understanding that assignment is what gives these values into that box. If we just create a box, it doesn't have a value. C++ cannot guess what needs to go in that box. It will not put something there for us. Assignment is everything about what we do when we're writing variables, and without it, it would be useless. So in order to use a variable, you have to create it. And then if you want anything useful to be inside that box that you were given, you have to assign a value to it. It may seem kind of strange that you have to, why can't you just create a variable and give it a value at the same time? And you can, and that's called initialization. Is when you create and assign a value at the same time. Now, one more thing that I'm going to say about these three. So both declaration and initialization are creating a new variable. When you create a new variable, you have created a new box in memory, you've given it a name, and now you are allowed to use the spot in memory based on that name. When you declare a variable, you only are allowed to declare it once. If you try to declare a variable twice, it's going to say, I can't do it. You already have a variable with that name. All right, this is an important thing to realize because you are only ever going to declare a variable once, and then after you've declared it, you're just going to use it. You're going to read it, you're going to write to it through assignment, but you're not going to declare it again, otherwise you are going to receive an error. All right, so let's see how to do these three. Again, I said long names, but the syntax could not be simpler. All right, so declaration. When we declare a variable in C++, what we're going to do is we're going to start with the data type. So I'm going to say int. There's going to be a space, and then we're going to give it a variable name. I'm going to call it my first variable. And then there's going to be a semicolon. Okay. So you start with the data type. Then you list the variable name. And a rule with variable names is that they should be descriptive of what they are being used for. I will occasionally use one-letter variable names in these presentations, but when you are writing real programs, you will almost never use single variable single letter variable names unless it is obvious why you are doing it. You should always give your variable names something that describes why they are there so that people who come on after you can understand what you were trying to do. All right. You can name a variable pretty much anything, but the restrictions are you have to start with a non-number. All right, so you can have almost any character inside a variable name. You can have underscores. I think you can have dollar signs, although nobody really does that. Any lowercase or uppercase letters, you can have numbers inside your variable names as well, but you just cannot start with a number. So I could not have int, the number 1 st variable. I couldn't do that. But as long as you're starting with a non-number and using characters after that, you're fine. All right, and then the last thing is when you declare a variable, your line needs to end with a semicolon. Statements in C++ end with semicolons, and variable declaration is no different. All right, so when I run this line, before this line, the variable myFirstVariable does not exist. After this line, if I were to look inside memory, I would see that there's a little box and that it has been named myFirstVariable. And C++ has said this thing, whatever you're going to do with it, it has to be an int, and it is not going to have a meaningful value because I haven't given it one. All I've done is I've declared it, and I have been given that space in memory. All right, so that was declaration. The second one is assignment. All right, when you assign a variable, what I'm going to do is I'm going to start with the name of the variable. So I'm going to say myFirstVariable equals 12. And breaking this apart, I have my variable name. I have a single equal sign. I have my value, and then, of course, a semicolon. All right, it's important to look that when you're doing assignment in C++, and pretty much any programming language, the assignment goes from right to left. Okay, so whatever value is right here is placed into there. So if I were to look at memory after this, remember I said that we have our box that is called myFirstVariable. After this statement is run, there's going to be a 12 in there. And I can read it out, I can do stuff with it. Whatever used to be there, whatever was in myFirstVariable before this line is gone, because after this line, it's going to be equal to 12. And when I put this value, it can be any number, but what's useful is that can also be another variable, or it could be a math function, it could be a bunch of different stuff, but whatever it is that's on the right over here is going to get assigned into the variable. All right, so we did declaration and assignment. The third one is initialization. Initialization is just a combination of declaring a variable and assigning it a value. If I were to ask you to guess what it is, you could probably figure it out. Initialization is just going to look like a combination of the two. So I first start with my data type. I give my variable a name. I'm going to call it myVar this time. Then I say equals 12 semicolon. All right. And this statement right here, again, I have my memory. After this statement is run, I am given a box. It is given a name of myVar. It has a type of int. And after this statement is run, it will already have a value of 12. Okay? So the difference between creating a variable and assigning a variable comes down to whether or not you specify the data type in front of it. If all I do is I say the data type, space, and then the name, I have created it but not given it a value. If I have the name of the variable equals a value with no data type, then I'm using a variable that already exists and giving it a new value. If I have the data type and the name of the variable equals a value, I am both creating it and assigning a value to it. And that's about it. That's all that it takes in order to create and give a name or give a value to a variable. All right, so if that makes sense, let's do a little quiz and see if you can figure out what's going on here. All right, so I am going to write down a program here. I'm going to say int a equals 5, semicolon. Int b equals 12. Then I'm going to say a equals b, semicolon. B equals a, semicolon. A equals 72. All right. This is a valid program, something that I just came up with. Pause your video and tell me, see if you can figure out at the end of these 5 lines, what is the value of A going to be and what is the value of B going to be. So go ahead and pause your video and try to figure that out. And hopefully, after you've done that, hopefully you picture something like this. Okay, so I'm going to draw memory again. And I have 2 boxes. I have one that's called A, and it is an integer. And I have one that is called B. The number of variables you can have in memory is almost unlimited. Especially when we're using small ones like this, you can have as many as you can put in. All right, so what happens, let's go line by line and understand what's happening here. So I say int a equals 5. What I do with that one is I've just created this box called A. I'm also assigning it a value, so this is initialization. So after this line is run, I have this up here. The very next line is to create another variable called B and give it a value of 12. So after these 2 first lines, this is what it looks like. I have 2 variables, one called A, one called B. A is storing a value of 5, B is storing a value of 12. You'll notice I don't specify any data types after this because now I'm just using variables that already exist. I'm done creating variables. All right, so the first line, A equals B. Remember what I said about assignment. Whenever you're doing assignment, you're always going from the value on the right into the value on the left. Okay, so what I'm doing is I'm saying, C++, please take the value that is in B and put it into A. All right, so when we look this up, we see that B currently has a value of 12. So I am saying take the value of 12 and put it into A. Since I'm doing an assignment on A, I completely lose what used to be in there. And now after this line is run, both A and B have a value of 12 inside it. On to the next line. Once again, I'm doing another assignment. The value of A gets stored into the value of B. I look over here and I see that A currently has a value of 12, and I am assigning it into the value of B. So whenever you do assignment, the value that used to be there is completely gone, and I see that I take 12 and I put it in B. In this instance, because B already had 12 in it, essentially there's no change, but C++ will actually make that change. It will actually remove 12 and put 12 in there. Last line, A equals 72. And when this does, I'm taking a value of 72, assigning it into A. What used to be in A is gone, and now a value of 72. So hopefully you were able to figure out that at the end of this, after these 5 lines, A is equal to 72. I'm not going to use an equal sign because I don't want to be confusing here. A is 72, B is 12. Okay, we're going to do this kind of stuff a lot, where we take the values of one variable and put it into another. We're also going to do math, and we're going to do a bunch of other stuff, but all assignment works the same way. It all uses the single equal sign, and it takes whatever value is on the right and puts it into the value on the left, overwriting whatever used to be there. All right, so before we go into Visual Studio and start playing around with this, the one more thing that I want to do is I want to talk about the rest of the data types. All right, so I kind of covered over them briefly here. 3 of them, there's integers, there's characters, there's floats. For completeness, I just want to tell you what the rest of them are. Some more data types. All right, the first one is a double. A double stands for a double precision floating point number. All right, so the first thing you should notice when I say that a double is a double precision floating point number is that up here, a float is a floating point number. A double is also a floating point number. The only difference is this double precision part. It's the same as float, but larger. So essentially, back when I was saying the data types, when I was saying these initial 3, that there was ints, chars, and floats, I said you could store almost any number in an integer and almost any number with a decimal point in a float. The limitation is the size, the amount of memory you have. All right. So when I create an integer or when I create a float, I get a box of memory, but I only get a certain amount of memory. There are limits to how big of a number I can store in an integer, and there is a limit to how much precision I can store inside a floating point number. All right. And you can go look these limits up. They are large, but it's not impossible and actually not that difficult to hit the limit of how much data you can store in one of these. So one of the solutions you can do, if you need something that has more, that is bigger than an int or has more precision than a float, is you can use these other data types. A double is just a larger version. Okay, so a double has, as you can imagine, hold double the precision, and it also takes up double the amount of memory. All right. The next one is called a long. This stands for a long integer, or long integer. This one is the same as int, but larger. All right, the same way that a double stores more precision than than a float, a long just stores bigger numbers than an integer. All right, so again, I don't have the limits memorized on what you can have in an integer, but if you ever hit that limit, and it's not impossible to do, the easiest solution is just to use a long instead. A long will give you more bytes to work with. You can store a larger number. All right, and the last useful type is a bool, which stands for a Boolean. Booleans are super simple, but also super useful. A Boolean can have exactly 2 values. It can either be true or it can be false. Nothing else. All right. It may not jump into your head what you would use a Boolean for when you first learn about them, but we are going to use Booleans all over the place. They are very, very, very useful when you're programming, and you are going to become very familiar with them. All right, one more thing before we jump over to Visual Studio. All right, in addition to all the different data types there are also called things called data type modifiers. All right. There are two of them, but we're only going to talk about one. And the one that we're going to talk about are signed and unsigned. They sound strange, but once you get them, they're actually really simple. Signed is the default that every data type is. It allows positive and negative numbers. All right. The point of the sign, when it says signed and unsigned, the sign it is talking about is the positive sign or the negative sign on a number. So when you have a signed when you have a signed value, that means you can store positive or negative values inside of it. Unsigned just means positive only. Okay, you cannot store a negative value in an unsigned variable. It may seem strange that they do this, and the question would be, why do they care? And the reason is simply because when you store a signed number, you have to use one of the bits to tell you whether or not a number is positive or negative. All right, the real thing that they use is called 2's complement, which is beyond the scope of what we're going to talk here. But what it essentially comes down to is that you need an extra bit. When you're using a signed integer, you need an extra bit to store whether or not a variable is positive or negative. And the default is to use that bit to say, is it positive or negative? If you declare an integer to be unsigned, then you get that bit to store information instead of storing whether a number is positive or negative. Okay. Using these is super simple. All you do is you just put them in front of the data type when you declare a variable. Okay. So really, you'll only ever see these on ints, longs, and chars. And even then on chars, it's a little strange, but the understanding why you can do that is beyond the scope of what we're going to do here. So we're only going to talk about these in terms of unsigned ints and unsigned longs. Okay, so if I want to declare an unsigned int, I just say unsigned int a equals 1. I can do in the same way that a long is just a bigger version of an int. I can say unsigned long b equals 2. Okay. When I run these two, I'm given a variable the same way that all the other previous declarations have worked, except in that box that C++ creates for me, there is no bit reserved for the sign, so it has to be positive, both of them. All right, I can use the signed modifier as well. I can say signed int c equals 3, and I can also say signed long d equals 4. I can do that, but it is almost completely pointless because the signed is by default. All right, so after I run these two, I get an integer and a long in memory that are allowed to have positive or negative. But when I create int c equals 3 and long d equals 4, I get the exact same thing as if I use signed int c equals 3 or signed long d equals 4. So nobody does it because there's no point. So the only modifier that you will really realistically see on a common basis is this unsigned int and unsigned long. And just know that whenever you see that, all it means is that those numbers cannot have negative values. All right. So with that, I think we've been talking long enough and writing in Notepad or in Journal for long enough. So let's go ahead and go to Visual Studio. I've already created a program here. Okay, and I'm just going to show off a few things that I've been saying here. All right, so if I want to create a variable, so that's all I do. Right there, what I've just done is, as I start off main, there is no such thing as a variable called myFirstVariable. But as soon as this line has run, now there will be something called myFirstVariable. All right. So what I can do, I'm going to use initialization here. I'm going to say my first variable equals 12. All right, and if I want to see what's inside my first variable, I can just use a cout statement and say my variable equals. And I can do that. All right. You can see what I've done here is I've just used one of cout's useful capabilities. Everything we've done up until this point, I've always been printing out either strings or endl. I can also put a variable right there. All right, and so what cout is going to do is it's going to print out the string my variable equals. It's going to print out whatever happens to be in my variable and print a new line. And we can build this and run it. And you can see my variable equals 12, just like we said. All right. We can split this into two parts. I can say I can do my declaration, then I can do my assignment separately. And so now you can see the declaration is up here on top, and my first variable, I am given a variable, but it doesn't have any value on it. And then on the next line, I give it a value, and then I print it out. If I compile it and run it, I get the same outcome. So you can see that initialization is just a combination of declaration and assignment. All right, so let's do a little bit more here. Let's go ahead and just type in that program that we had done before where I was creating A and assigning it to B and doing all of those things. Let's see what happens here. All right, so let's type that into a program and see what I was talking about and make sure that I wasn't wrong. All right, so I said int A equals 10. Sorry, no, I said int A equals 5, int B equals 12. Then I said A equals B, B equals A, and then A equals 72. All right, and I can see what these are equal to by just printing out the values. Okay, so I'm going to say cout A equals, and then I'm going to print the value that's in A, and then I'm going to say B equals, and I'm going to print out the value that was in B. And if I do this right, B should be equal to 12 and A should be equal to 72, and as you can see, it is. Okay, so the same stuff that I showed you slowly in Journal, you can see that I was telling the truth. A is equal to 5 and B equals equal to 12 at the start. When I set A or B equal to A, that means A is now equal to 12 and B is equal to 12. When I set B back equal to A, now, well, they're both 12, so that has virtually no impact. And then when I say A equals 72, A is given a value of 72. And you can see after that, A equals 72, B equals 12. All right, let's just show a few more things here. Let's play around with unsigned just a tiny bit. Let's say unsigned int A equals 10. And then int B equals 10, and print these out. So now when I do that, A and B are both the same, and that shouldn't be a surprise because both A and B, I just gave it a value of 10, and neither one of these has a minus sign, so you're not going to see a difference between an unsigned int and a regular int. Okay, but now let's see what happens when I try to assign a negative value to each one. Now I get something interesting. You'll notice it didn't fail. Assigning a negative value to an unsigned int is not a failure. But what you will see is that when I had an int b equals minus 10, I get this exactly what I would expect, b equals minus 10. But when I assign a equal to negative 10, whoa, I get, I don't even know what this is, looks like maybe 42 million, 42 billion. I get a really, really, really large value. And this right here is just a representative of the fact that that int cannot hold a negative value because I didn't allow it to. It was able to go to a really big value instead. Okay, so that right there kind of shows off that this a, it may be a really big value, but it's a really big positive value because it was not able to hold that negative value inside of it. All right. Let's just go through how you create the other types of variables. Okay, so if I say, we've already been doing integers, let's just go down the list of what we have here. Okay, so if I want to create a character, let's just do them all. Int a equals 10. I've been doing that a bunch. All right, so if I want to create a character, I'm going to say char b, and if I want to give it a value, characters are specified by being surrounded by single quotes. Before, we've always been using strings, which use double quotes, but when I use a character, I can only hold one, and so I'm going to use a single quote to save something in here. Okay, so I'm going to save maybe an exclamation mark in there. Why not? All right, so I say char b equals an exclamation mark. If I run it now, you can see C++ was smart enough to say b is a character, not an integer, and it's going to store an exclamation mark. And when I print it out, sure enough, b equals exclamation mark. It was able to store that data. Moving on. If I do float c equals 1.2, and then I try to print it out, there we go, c equals 1.2. So now I was able to store that decimal point value. If I try to do that on an integer, and a equals 1.2, once again you see I didn't get an error. It's just the same way as when I put a negative 10 into an unsigned int. I don't get an error, but you'll notice it didn't work. C++ said no, a is an integer. I cannot store a decimal point, and so you can see that it rounded it. It rounded it down to 1. All right, so let's get rid of that error. All right, the other types that we've covered, double d equals 1.5. It shouldn't be a big surprise that when I declare double, I get the same. Whoops. Oh, well, you look at that. I wasn't actually printing C out. Huh. All right, well, we'll print it out this next time. All right, so now I'm actually printing out C and I'm actually printing out D. All right, it shouldn't be a surprise that when I do this, boom, it actually prints out the value that's in C, which is 1.2. It prints out the value that's in D, 1.5. This float and this double are very difficult to tell apart. If you were to actually look at the memory, you would see that the value in D is twice as big as the value in C. And you would also realize that D is able to hold more values than C. All right. Next one was a long. So long E equals 10, and I'll store 15 in it, why not? The same way that a long and an int were hard to tell apart, or the same way that a float and a double were hard to tell apart, an int and a long are hard to tell apart. There we go. So I created a long E, and I gave it a value of 15. It looks exactly the same as an integer. Again, if I were to look in the memory, I would see that the long is twice as large as the integer, but that's difficult to see, and it's also a long can hold more values. But for all intents and purposes, as you're using them, they're going to act the same. All right, and the final one, the interesting one, we're going to create a bool, f equals true. All right, the word true and the word false, you'll notice they turn blue. That's because these are special values in C++. You are allowed to use them in the same way that you would use numbers, and you have to assign them. You have to assign them to a Boolean when you use them, okay? So I just create a Boolean which can only be true or false. And when I print it out, now notice here, when I assigned a value of true to f, and I tried to print it out, it said f equals 1. If I assign a value false, it says f equals 0. If you're wondering why that is, what you can basically see is that C++, there's no actual, it's not like it's storing the value true inside of memory when you create a Boolean. It's not actually storing true or false. What C++ does is inside memory, it considers a 0 to be false, and it considers anything other than a 0 to be true. All right. So whenever I create a variable that's a Boolean, it can be true or false, but if I look under the hood even a little bit, I'm going to see that false is 0 and anything other than false or anything other than 0 is true. Okay, so when I say Boolean f equals true and I try to print it out, it's going to say 1. All right, but Booleans are very useful. That's what they're going to be used for. All right, last thing, we're going to go over some common mistakes. All right, the most common one. Let's do this. Say a equals 5 and then try to print the value out. There were build errors. Would you like to continue? No. A, undeclared identifier. I've been using the word variable for the entire time here, but as far as the C++ compiler is concerned, when you create a variable, it's known as an identifier. And what this is saying, A, undeclared identifier, what it's saying is you are trying to assign a value to A, but A has not been declared as a variable. You're trying to put a value into a box that doesn't exist yet. If you get undeclared identifier, what it means is C++ is guessing that you tried to use a variable that doesn't exist. I say that C++ is guessing because what you are going to see is anytime C++ sees a value, something that it doesn't understand, it's probably going to call it an undeclared identifier. We've already seen it in previous videos. And sometimes, and this is an example where it is true, sometimes undeclared identifier means that you have tried to use a variable that has not been declared yet. Sometimes it doesn't. But that is what it means when it says undeclared identifier. It means you are creating a variable, or you are trying to use a variable without having declared it first. You will also see that you get the same error if I try to print out a variable that doesn't exist. So you can see I tried to see out the variable A, said A undeclared identifier, because I haven't actually created it yet. All right, the next error that you'll see is actually not a compiler error. Ooh, but it is a runtime error, and you will see these. Now check this out, what it's saying. Debug error. Program this one. Runtime check failure number 3. The variable A is being used without being initialized. Abort, retry, ignore. I'm just going to abort. Who cares? C++ is trying to save you from yourself. So what you've done here is you have created a variable, you've declared it, but you have not given it a value. Back here, when I was looking at memory, I have a box, but I haven't put anything in it yet. Okay. This is the picture that we were looking at, where we create a variable, but we don't actually give it a value. And if you do that, C++, sometimes it will yell at you, sometimes it won't. Okay. If it doesn't yell at you, all you're going to have is you're going to have a garbage value in there, and you're not going to know why it's there. Usually on Windows, it's negative 858 million. But whatever it is, if you try to use a variable before you've given it a value, it's probably going to throw up on you. You need to give variables values, and you want to always get in a habit of assigning a value as soon as you create a variable. All right, let's look at just a few more here. And actually, we'll only look at one more. Okay, and this one's just a common one, and so it's worth showing. Syntax error, missing semicolon before identifier cout. Once again, I get this error down on the cout line, but the real error is on the line before it. And all it is I tried to initialize a variable without a semicolon. All of your statements in C++ need semicolons at the end. Put it back, and now the program runs again. All right, so that was a pretty long video, but variables are that important. They are used all over the place. You have to understand what variables are doing and how they are being used. In the next video, what we're going to do is we're going to take a look. We're going to build a little bit on how variables are used, but we're going to look at how to do math with variables and also Boolean expressions. Those Booleans that we just barely touched on here, we're going to get much more into depth into what you can do with those. All right, until the next time.